the point of this lecture is about checkpointing. So the first question is, what is checkpointing? And actually, Damien already told you. But let me give you a very simple example. So let's assume I have an extremely complex PhD level program, which is count. And as you can guess, count is doing 1, 2, 3. And then suddenly I realize, oh, I make a mistake or whatever, then I'm canceling my job. And if I now restart the program, what do you expect is, I mean, the normal program will restart to count at 1, obviously, which means that you are losing every computation you have done before. So of course, this example is completely stupid. We are going to use that for the full lectures, but you need to think that this is a real computations or whatever kind of science you are doing. And then of course, you don't want always, at least not always, to restart from scratch. So this is the normal behavior of all your program. That's what we call without checkpointing. And what you are going to learn during these lectures is basically how to restart from basically where you have stopped and therefore not losing your computation. Okay, so in definition style, in a way, checkpointing is to save your computations so that you can resume it later. Simple as that. So why would you need checkpointing? There are 4 reasons, but the main one is this one, is the wall time. So as Damien told you this morning, right? Yeah. We put wall time, and I personally like to have extremely short wall time. Because if we put wall time of 20 days, people will think, oh, I finally my CPU, and they will not launch it for 20 days, even if that means launching 20 tasks of 1 day each. And they just put one job of 20 days. And I say, I have one CPU, I can keep it forever, which is basically pointless because then you cannot have other people using those resources, basically. And launching 20 jobs of 1 job is much more efficient even for you than even launching 1 of 20 days. So I personally like to have extremely small wall time. I would say 6 hours for me, it's perfect. Don't worry, on CC, it's typically 2-3 days. But basically what it means is that we have to wait, of course, for your job. Then it's running. And at some point, you will going to be killed by the wall time. And what you want to do is then put you back in the queue and then rerunning just up to the completion of your code. So if your job is longer than 2 days, or if you want to use the debug partitions, where basically it's free, that's completely for yourself, but it's only 6 hours, then you can use that and you will gain quite a lot. And then you don't need to worry too much about what exact wall time do I put. You can put something quite short. Then you are backfilled, you are running like crazy, and basically you are a peace of mind because you know your job are going to finish whatever. The second reason it's more rare is debugging. So if at some point your code is crashing, you can check basically at the checkpoint what is the status, fix the bug and rerun. That's typically never happening basically, because you need to have a checkpoint which is not yet impacted and stuff like that, but sometimes it's happened. One place where it can happen more often is that suddenly the node on which you are running, someone else is running, and basically the computer dies because it has no memory anymore, no file system or whatever, and then you can restart from the last checkpoint. That's happening more often, let's say. And the final reason we don't have that on CC cluster, we have that on man-back actually, is that if you have a job with higher priority than you, sometimes your job can be suspended. It's not really killed, it's just put on pause so that you can basically, the higher priority job can run, and then when those jobs are finished, then you can restart. So we are using that on man-back for the GPU partitions, for example. But in that case, if you don't have checkpointing, then you have to restart from scratch, which would be a waste of time. So this part, I mean, we have a dedicated QoS, if I'm correct, only for that on man-back, but then checkpointing there is super useful, obviously. Okay, so let's have some fun. I can, yeah, and then try. So, shit, I didn't think about that. Let me move it here. We go directly to the first questions. You have the link here, so you can go to WooClap and then enter this code. And it's just an open question, so I can just think a bit about it. So what kind of strategy do you think you are going to implement, or you want to implement for checkpointing? So basically, what is the strategy? When do you want to checkpoint your code? I'm going to. So if you have your favorite jobs, how are you going to plan to checkpoint your jobs? If I ask you, you have one job, how do you going to think? Do you want to? I will see the answer. There is no bad answer, basically. One answer so far. Still waiting, let's say, for 2 or 3 answers. There's no bad answer here, actually. I personally have 3 different answers, but maybe there will be some other good one. Okay, let's try to have a look at the answer. Yeah. No, that's not what I want. Look up is here. Oh, cool. Okay, let's look at maybe this one first. So I want to arrive at almost at the end, maybe if I put like this. Maybe, yes. Temporary files. So that's more, yeah, that's technical solutions. You can put stuff in temporary file. That's good. Output result from time to time. When the simulation launches simulation code checks whether it was too long. Where it was in the continuous simulations, yes. So here I would say what's important for me is the word time to time. So I want to have some regular checkpointing almost at the end, which is also a very good one. Set if and else conditions, then that one I don't see too much. Dividing the program into parts. That's what we are not going to do actually, but that's also a nice way to do it. That's quite heavy in terms of change of program actually. Put a checkpoint at each step for a job and that there's a lot of iterations. Yes, that's typically a lot of people are doing that. That's 2. Split jobs we already said, and saving computations. After each iterations, segmentations of the code, and checkpoint at every iterations. So yes, so that's what I would say my 3 answers, and then you cover all of them, even a bit more actually. So for me, I want either to do a checkpointing every X minutes, or every 1 hour, or every 30 seconds. I mean, for the demo, I will do it very, very often, but typically not so often to do. And you said after each iterations, that's a good point to do the saving, and basically just before the program is skipped. Someone also provide that. For the other answer, what's at the end? Dividing the program into parts is also, of course, a very good strategy, but that's requires quite a lot of work, obviously, which can be beneficial for your code if you can do it, obviously, but sometimes it's just not possible. Okay. So that's basically what we are going to do today. The first thing is how to change your program to do at each iterations, and then how to do checkpointing on demand. So basically when it's needed. So that's basically just before your program is going to be killed, and also every X seconds. But that's mainly, this one is only useful when you cannot change the program at all. When you can change the program doing the checkpoint at each iterations, that's typically the most efficient way, because you know exactly what to save. When you can change a program, then you can do every X minutes, basically. Then it's completely blind, and we'll cover that later. Okay, the first thing before going that is that if you are not creating your own software, the first thing to check is the software you are using is able to do checkpointing for you or not. So many scientific software have way to do checkpointing, and then you just have to read the manual, obviously, and just use what they do. And in that case, you don't have to do anything. That's simple for you. What we are going to do is actually changing the code that you've seen before, the count code, in order to do checkpointing. So the first demo is add a checkpointing stage after each iteration. So now I would have the issue. Let's see. No. Yes, good. Yes, perfect. Don't forget for the one this part of the screen. That will be useful later. Just look at this one. And you will have all the, I mean, you should have the table normally of all the examples in the Indico. Can you check, Damien, if it's there actually, the table? Otherwise, it's at the usual place. So /cc /proj /training /checkpoint.
Yes, you can download it from the Nico.
From the Nico. Don't. Okay. So we can see the full file, but that's fine. So this is a simple program that do count, and there are quite a lot of stuff that we don't need in practice, which are those lines, C-type, P-type, blah, blah, blah. Those are mainly a lot of comments to avoid any buffering on the cluster. So that's basically there is a lot of what we call buffering, which is basically instead of seeing, writing on file directly on real time, it's basically we are waiting 1 minute before writing on the actual file. And since for my demo, I want to have everything super interactive, I don't want to have any buffering. So I'm quite often using those kind of stuff which are completely irrelevant for the Python part, but are just allowing me to bypass any type of buffering. So basically you can see those number 1, 2, 3 printing on the screen in real time, even on the cluster. What that code is doing, I will just go down. It's just a for loop. So this is Python, starting from start and stopping at 500, and basically printing the number. So that's basically the stupid stuff. And here, after each iteration, what I'm doing, I'm opening the file state, and I'm writing the number, actually the next number that I have to write. Again, this line is just to avoid any delay in writing. And then if I'm going back here, when I'm starting my program, I'm checking if the file state exists. If it doesn't exist, I'm starting to go at 1. If it exists, I'm restarting from here. So that's allowing me to cancel the job at any time. I will have the number, I can restart from there. Okay, so that's a very simple example, super clear. And that's typical stuff that you do at each iteration. At each iteration, you know exactly what are the important information. You dump that into a file, and then you restart if the file is there. So it looks like I already had a file, so that's why I'm starting at 22. I can cancel my job at any time. If I'm restarting, I'm continuing when I start. No surprise, super clear. Is there any questions on this? At this level, it's more for putting the stage for where we are going to start to do real stuff later. This stage is, I would say, a bit boring, but if there's any stuff that you don't understand, please ask me.
So all the numbers are written in some file which is open and closed with every.
At this stage, at every iteration, yes.
So you open, close,
yes. Yes. I mean, obviously, I'm going to do in those demonstrations everything that Damien told you not to do today. So I'm going to submit jobs of 1 minute when Damien told you never doing job of 1 minute. This I'm going SQ for the ones that what this window. I'm doing SQ every 2 seconds. That's also something that Damien told you not to do. So sorry, Damien, I'm presenting bad example all the time. That's just for the demo. And then yes, I mean, this example makes no sense, obviously, right? in a way. You need to think that each iteration takes at least a couple of minutes before doing a checkpoint. Doing a checkpoint every second, yeah, it's pointless. You don't want to pass more time on the checkpointing part than on the actual computation, so you sleep, which on this code is probably the same. And most of the time you sleep in this case. Up. Yes. So now I want to, the real trick to me is not to do the checkpointing after each iteration, which is trivial to my point of view, is to do it when I need. And what I call that, basically when I need, is basically when I'm canceling my job. So instead of, as you said, writing all the time the file, basically at some point I cancel my job, and I want to write only at that time. And for that, I need to know how in Unix we use signals. Because basically when I'm canceling a job and sending information to the process, or you need to cancel, and basically I want him to dot cancel directly, do the checkpointing, and then cancel. So what is signal is basically message sent between different processes. So you can send signal to a process yourself, or it can be the OS that sends the signal, or even other process. And you have, this is the list of the standard signal. We have a long list actually, but some of them you might actually know. Who has used already Control-C, for example? I guess some people, nobody? Come on. Yeah. So Control-C is actually a signal, which we're going to use quite often, which has a name, signal int for interruptions, which has a code that nobody cares too much. And by default, the code is going to exit when you receive it. That's its default behavior. We have also Control-D that some of you have used. Control-Z that was explained on Tuesday. If you want to put a program to sleep, so not kill, but just suspend it, that's Control-Z. And if you want to restart, I typically do FG for foreground or BG for background. And I learned actually on Tuesday that you can also use the %. I was not aware of that syntax. Or you can use the kill command, kill -9, if you want really to have a hard kill of a process, or just kill, which by default send a signal 15. That's a way for you to send a signal to the job that he has to do something. It can be ignoring the signal, or basically most of the time stop. There is also, Slurm is going to send sometimes signal as well. If you realize that, oh, you are using too much memory, Slurm is going to send a signal to your job that he has to cancel as well, for example. So what is interesting, and then, yeah, one thing I have to, where they are, there is also two signal user 1 and signal user 2, that are designed for user to use and do whatever they want. So there is no default. Actually, yes, actually I'm wrong. There is a default which is exit, but you can use those signals relatively freely because basically nothing is designed for them by default. And we're going to use it today, actually. Okay. So now I'm going to use the signal, and I'm going to intercept the Control-C, and I'm doing a checkpoint when I'm canceling the job before quitting. Okay. I'm doing that only for Python. In principle, it's also tarball available in Bash. I don't remember all the language you did. In the,
C, R.
Yeah, in many different languages, it's always the same ID, basically. Fortran, I mean, any language has these capabilities because it's a basic Linux capabilities, basically. So the syntax itself is not that important. What this line means is that when my program receives this signal, which is sigint, so that's Control-C, when you type Control-C, run these functions. So the function is defined here, and what the function is to change a global variable interrupted from false to true. Now what I'm doing, that I'm running normally, ignoring completely everything Control-C, but if interrupted is on true, then I'm stopping this loop. And then whatever is happening when I'm quitting my program, I'm writing now the checkpointing, basically, only on exit, and then I'm quitting. So now, basically, I'm going to run my program. I'm never doing any checkpointing at any stage. When I'm canceling my job, I'm saving the state, and then I'm quitting. And yeah, here, just to be nice, since it's interrupted, I exit with 1, so that is saying it's not a normal termination. But okay, that used to be beautiful in a way. Okay. So the demo will basically be the same. So if I'm running the code, you don't see that much difference. The only way I'm going to suspend the code, so not I did Control Z and not Control C, so I didn't kill the program, just suspend it. And now if I'm checking my state, you see that I'm still at 111. So my checkpointing is not updated iteration after iterations anymore. And now if I'm actually killing my job with Control C, you see that it's setting the state to 123. So it's doing the checkpointing when I kill the jobs. And if I'm restarting, I'm indeed restarting from 123. Okay, so that's much nicer in a way, because now basically it's when I kill my job that my job is saving itself. Okay.
Question.
Yes.
Does this work or apply if there is electricity shutdown?
Electricity shutdown, no. No.
But they have some station that allows it to continue working.
So yeah, I'm doing really the checkpointing when the job receives a given signal. When there's a shutdown, basically everything will stop working from one go. So I will not receive the signal. I will not have the time to do the checkpointing, basically.
But you don't have like generators that allow you to work in this electrical shutdown?
Yes, yes, yes. In our case, yes. On your laptop, no.
Yeah, yeah.
And here we have, I mean, yeah, I mean, with this, I will not guarantee that it is going to work with this method, because I'm not sure that the signal will be sent and the correct signal on top of that. It might be directly catastrophic, that basically a signal that cannot be interrupted and basically kill everything. That, I mean, I don't know the details there.
The generator and UPS will only run for the basic services, but not for computing.
Yeah.
We'll shut everything so that we know that the management services can keep running.
Yeah, the point, I mean, we have basically normally 30 minutes of whatever. So cooling, electricity, we have a backup for 30 minutes. So as soon as we realize that, oh, there's no electricity anymore for more than 5 minutes, I think, I mean, don't quote me on the number, then we'll start to cancel all the jobs and shut down all the nodes of the cluster, so that we have more electricity and more cooling for what is important, which are the main server, the disk file system, and stuff like that. Because if those are shut down, then we are, I mean, it takes days to restart everything. But the compute know that's easy. That has been also, we are quite aggressive on those. And I mean, for the cluster here, we don't have generator. So we really have battery and that's it. We have another cluster in the cyclotron where there is a generator, but that's for it's not for us. Okay. Any other questions? Yes.
How do you know which codes Ceci is going to send you if you beat the time?
I'm going to that. So keep your questions, and it should be answered. If you're not happy with the answer, come back to me. Okay. Okay. So that's basically I'm starting in your directions in a way. So far, I've done everything in a way on my laptop. I was running on Lemaitre, but basically I was not using Slurm at least so far. So now I want to use the same technology, but on Slurm. So the first things you can do is use scancel. So scancel is not only a way to cancel your job, but also to send any signal to your job. So if you want by hand to start a checkpoint, it's not super useful, but in principle, you can do this. Scancel minus S, the signal that you want. So this one is Control C, then your job ID. Then you will send Control C to your job. If your job is the one before, then your job will checkpoint and quit. That's one way. It's a bit boring way, but that's a way that's worked. The only very useful case is that's one of your friends want to pass some jobs, and then you really want to to let him go in a way, that you want to cancel your jobs, that's a way, but basically it's not very useful, I would say. So now this is actually your questions. So how to tell Slurm to basically start the checkpointing for you. And there is this command, which is -- signal, which is going to send a signal, and then you have the @ here. So I don't have an example in this slide, but we'll see later. You can specify even the time before your gens is going to be canceled. So you can send a signal 1 minute before the whole time. But if your checkpointing takes 5 minutes, then you can specify here 10 minutes, so that you're going to receive this signal 10 minutes before the whole time. So that give you now, that allow you to basically parameterize how much time you need to do the checkpointing. And you can choose yourself which signal. So you can use Control-C, or you can use signal user 1, signal user 2, whatever. Okay. And there is a small variations. So you have two syntax, one with B and double dot, so colon, or without it. So in that case, the signal will be sent to the srun command, and here the signal will be sent to the bash script. That's the difference between the two. Not sure you can you read? Oh, it's too difficult. You can read, yes? Okay. So one thing important on top of that for Slurm is to basically, where is it actually? No. It's here, it's the third one. It's the append. So you don't want, when you resubmit your jobs, you don't want to overwrite your file. So typically you want to be in append mode, to add at the end of the file. For the rest, it's exactly like before. You're going to load your module, Python, that doesn't matter. Use srun with your command, and then count signal. In this case, I send a signal Control-C 60 seconds before the end of the world, before the world time, and that's more than enough time to basically cancel this job. Okay. A small variations, and that's because I'm going to add one thing, which is, I think there was someone asking the questions on the first day, or if we need to requeue automatically or not. So here I want to automatically requeue my jobs. So my job is canceled. I want to restart basically directly, and then I want Slurm to basically, I don't need to do anything. I don't need to resubmit myself. So that's one case when I'm using this B colon here. And now the signal will be sent to this bash script. So now it's useful, the bash scripting session that you had on Tuesday. It's basically this is saying, when I receive signal, in this case it's user 1, run the function's timeout, and that's the definition of the function's timeout, which is doing, the first thing is to send Control-C to my jobs, and that's, I'm using this scancel -s that I was showing you before, and then I'm using scontrol requeue and my job ID. Then it's resubmitting my job automatically. Okay, and for the rest, it's basically the same. One thing you need to, it's important to be in the asynchronous mode that you also see on Tuesday. So you need to do this ampersand and then this wait. If you don't put the wait, the job will finish directly, it's bad. If you don't put the ampersand and wait, then basically the signal will be lost. So that's bad as well. Okay? So let's do the demo. Okay. I'm sending the signal 30 seconds before the whole time. In principle, this is not super accurate. So you see the signal will be sent super quickly after 5-10 seconds. I will receive the message actually. Because normally Slurm try to be accurate up to 1 minute, which is basically the time of this. So the signal will be sent super quickly. And then for the rest is the option that you've seen today. I'm running on the debug partitions, but that's not too critical. And the script itself is just running the counting that I was showing you before. So the one that not doing checkpointing every second, but the one that's only doing checkpointing when I receive Control C. Okay. Okay. So it is submitted, and now you can see the usefulness of this part. So this is a window that is running SQ every 2 seconds. So I can see in real time what's happening to my jobs actually. And you see that, can you run the magic command, please? You see that my job is running, is not running to be running for very long. Now it's starting to take quite a lot of time, obviously. Okay, now my job has been canceled, and you see that it's back in pending because I requeue. When you requeue, you are not allowed to restart directly your jobs. You are always, I mean, it's automatically set slightly in the future, just to avoid that if your job is completely crashing, that it's resubmitting itself too quickly, basically. So that's why it's in the reason is basically that the bugging time is in the future. So it's basically do that. Actually, that was the case already before. So that's actually the second restart I've done. And what Damien just did is to use the superpower to change the bugging time in the past and increase the priority of this job to basically infinity, just for the demo so that I can run basically whatever I want. So thanks, Damien, for doing that. Just wait before redoing it. So here is the output. You see I'm restarting to count up to 150, and then here my job was canceled, but just before it was saved. So now, Damien, if you can use your magic power again, you see that it's restarting again. So Damien does, in principle, you don't have to ask Damien to restart your jobs. It's just going to come automatically. I'm just I'm not patient enough in a way. 5 minutes for demo is too long. And then you see that it was restarting, no problem at all. Okay, and of course, cancel very quickly because I asked a very short wait time. Okay. And now canceling it completely. Yes, just so that I can start the next demo without having. Otherwise, it will continue forever. Okay, any questions on this? Yes?
So my error message is about the memory.
Yeah, you will have the same issue in that case.
Sorry?
In that case, you will have the same issue. Again, you are going to restart to use too much memory, and it will be killed. But with this mode, it's requeue only if you send the whole time, basically, right? So if I'm going to this script, you see the requeue. I need to do it here. You see the requeue is part of the timeout functions, and the timeout function is only used when I hit the whole time. So if your job is canceled for whatever other reason, like not enough memory, in that case, you don't run through the checkpointing.
Yeah, is there any
Well, having different strategy of checkpointing, I would say. Because you can combine the strategy of checkpointing, right? And I will have an example later. But what you can do is a checkpoint every each iterations, and a checkpoint on demand on the whole time. It depends how heavy is your checkpoint, right? I mean, in this case, checkpointing is super, I mean, it's writing one file, it's super fast. If you need to save 1 terabyte of data, then you don't want to save, I mean, you don't want to do that every 5 minutes, right? But, and that's depending on how easy, complicated your program is. So it's difficult to answer. But yes, I mean, it can take, it can be heavy to do checkpointing, obviously. And in that case, you don't want to do it too often. Or it's super light like here, then in a way, you probably don't want to do every second, but you can do it from time to time, right? And that,
example of the C is right, like any signal entry point.
I mean, you can do, I mean, you can use more when it's out of memory. It's also a sequence of signal, right? I don't know which signal. I think it's also start Slurm, send first a control C, and then very quickly it sends a kill -9, which is the highest. And then after that, I don't remember what it's doing. But then in that case, you don't have the opportunity to basically schedule the message, right? With the ---- signal here, you can say that I'm sending the message 30 seconds before. So you know that you have time to do checkpointing. For memory and stuff like that, you don't have that much freedom. So if it's fast enough, then it can go through. And I don't know how much times, do you know the time for the two signals sent by Slurm?
The parameter in Slurm is called kill wait. So if you ask control show config and look for kill wait, you will see how many seconds between seek int and seek kill are sent.
Yeah, but that's parameter at the system level, so you cannot configure it yourself. All right. Okay. Any other questions? Yes.
How can I know what is the communication cost of the environment?
I would say like in the previous, I mean, like this morning, right? The only way is to measure it. Which means you need to make, you run a test and then you track how much time it takes with checkpointing, without checkpointing, so in order to know how many seconds you need. Yeah, that really depends. So. Okay. How much time you have left? Okay, so it's okay, it's good. Yeah, let me skip the questions on Booklab because otherwise it's complicated. So now the last part of the talk is being able to do the same, but now with a program where you have no clue what it is. So let's think about a program like Mathematica or a program, a not-free program, so with license, where you have no code what the code is, and you just have a binary, so you have no way to add basically a step within the code. So what we are going to try to do is to checkpoint those programs without changing the code at all, because you have no control on the code. So basically what we are going to do is what I call snapshots. So basically we take a camera and basically stop the program at a given time and basically dump all the memory. So it's a bit more complex than that, because it's not only the RAM that you are going to dump, but also all, I mean, communications that are open between different nodes, like MPI communications, the status of Slurm and stuff like that. So you have different stuff that you actually dump on file. I don't know all details, it's not important, but basically the idea is you take what is on RAM and you write it on disk. That's the main idea. So there are 3 programs that can do that. There is BLCR, CRIU, and DMTCP. And I've taken one slide from Rodriguez Pascual that was comparing the 3 of them. Basically, BLCR is the only one that supports Slurm, but the one I'm going to show you today is actually DMTCP. So you will see it's running with Slurm without any problem. You'll see also that it supports MPI, and the cool stuff is that you don't need to modify your applications at all, which is the case for BLCR. So you need to recompile. And also, which is important for us, you can checkpoint, you have a nice support of InfiniBand. So for MPI applications. Okay. So how does it work? So basically, when you submit a job, you need first to do a modulo DMTCP, and then you launch your executables by prefixing with DMTCP launch. In practice, what's going to happen, you will have 2 processes running. one what is called the DMTCP coordinator, and one which is your actual run. And then if you run at any point DMTCP command ---- checkpoint, what's going to happen is that you're actually stopping your process here, saving the state in file, and then you can redo that multiple times. Each time you save a checkpoint, it will create a script, DMTCP restart, and a lot of gibberish. But the only one that you are really interested in is the DMTCP restart script, which is a symlink to the latest one, actually. So then if you hit the whole time, you can run this, and then you restart, in this case, from the last one. Obviously, you can lose a bit of your computations time, but if you do that regularly enough, then you don't lose too much. Okay. So in DMTCP, you have two modes. One mode, which is exactly like this, in a way, which is by default, you do a checkpointing every X seconds. So in that case, you have regular checkpoints, and therefore, whatever happening, you have the last checkpoint. And you have also a mode which is on request, so you can launch the checkpointing when there is a given signal. So again, you can use basically the fact that, oh, I'm close to the wall time, and I'm starting to do the checkpointing just before, exactly like the same technology as before. So the code itself, I'm not showing the full script here because there is a lot of dark magic, I would say, behind this command start coordinator. That's a Slurm script. But basically, this line is starting the coordinator, trying to reconnect to another one if it already exists, but that's not that important for you. And in this case, doing a checkpoint every 10 seconds. Then when you run this srun command, you need to prefix with the DMTCP launch. That's the important point to basically connect to the coordinator. In this case, it's important for the method 3 and maybe other clusters, I didn't check on those, ---- holo file override. And this is also very specific to the method 3 because we use some security, and that's basically to bypass some of those security. Otherwise, we have files that you cannot basically touch. And the last flag that is useful is --rm, which is for resource manager, so that it can basically have some interaction with Slurm more easily. That's the point. Okay. When you have that, when it crashes, it creates a script, and therefore you can resubmit in the same way. In this case, you do restart script, and then some options as well. So now that's basically in this case, you don't have automatic resubmitting. So it's one way, the first script you do checkpoint every 10 seconds, and in that way you resubmit. Okay. Any questions on this? Okay, so now we are going to combine everything that we have learned into a single script, super useful script. So I'm going to use DMTCP to do a checkpoint, I guess, every 10 seconds. We'll check how quickly, how often I'm doing it. And I'm adding an additional checkpoint just before the whole time and auto resubmit as well. So basically with that script, whatever is happening, you are covered, basically. So what do we do? So that's the solutions. The first thing is that I'm starting the coordinator. So that's a complex function. So we'll show you the functions, but basically you have to copy paste it. That's it. Every 10 seconds in this case. Then the second thing I'm doing is that 60 seconds before the whole time, I'm sending a signal to this bash script. And this signal will be intercepted by the function's timeout. That's the meaning of this line. And what the timeout is doing is starting a checkpoint, sleep a couple of seconds, then quitting DMTCP and requeuing my job. That's what it's doing. Okay. In order to do that, since I'm sending a signal to the bash, I need those ampersands here to avoid that my code is stuck, and I need the weights at the end of the program. Okay. And finally, auto resubmit. So I already showed this kind of S control requeue. I also need the append to not lose basically the log file or the output. And those lines are specific for the method tree. And I have it here, the if statement, that if I don't have any jobs, launch anything before, then I'm running the normal command. Otherwise, I'm running the DMTCP restart. Okay? Questions? Or we go to the demo?
The 2 seconds lead is to give time to the checkpoint to do it.
Yeah. Yes. I mean, this one for sure is not necessary. This one, yes. I mean, 2 seconds is a bit too long here, but yeah. You need to leave it, give it time basically to finish. So let's go to the demo. So I'm submitting via Slurm, so S-batch. And in this case, maybe I should show the script before. Slurm DMTCP solution sub. So that's exactly the same script as before. The signal, I changed it, I reduced to 30 seconds. So that's super, super quick. So here you have the function start coordinator that you just have to copy paste. I take it directly copy paste it from DMTCP documentations actually. That's echo. And here you have my module. What is important is to load module DMTCP, because otherwise it will not work. And then the coordinator, which is indeed at 10 seconds. And then here, if I don't have a checkpoint, start the program, otherwise restart from the checkpoint. The functions here to what do I do when I eat the whole time, and then the wait at the end. Okay.
Maybe you can show the program that you start to show that there is no logic in the program itself.
Sure. So the program, well, yeah. Don't see the same. So the program I'm using here is count Orish that I didn't show you yet, actually. It's a good point. Okay. You see here, it's just a for loop and a print. So in this case, I didn't change that. I access to the source, but basically you don't need to know what's inside. There's no logic, no change to the code whatsoever. Again, yes, I put that whether it's buffering, but that's not critical. So solutions. So you see that now I have my job, which is running, which should write a file. So it's starting to 10, it's still running, so it's continuing. So that's the annoying part of those demos. Then when we decide to run a bit longer. Now at the whole time. Okay. What's going on? Finally, doing checkpoints. My word time was 1 minute, right? Okay, maybe
1 minute is too small compared to the resolution of.
Yeah, I know, but normally it's faster than that. But you see, it was doing the checkpoint was done, and then the job was cancelled due to job. I mean, you don't see resubmissions actually. And you see here that again, my job is ready to restart, but in the future, except if Damien allow me to restart directly, which is now the case. So now I'm rerunning. And you will see here that is going to restart. So here there is a small buffering that I'm not able to cancel. But yeah, you see, it's restarting content. So now if I'm looking, you will see that I have, well, you don't see that much resolution in time, but you see that now this file is updating every 10 seconds. So it's still running. So before, I mean, no, well, it's difficult. So that's F7, the one. If I'm redoing now, still F7. No, it's changed, right? Yeah, it has changed a bit, but maybe not the first letter, maybe the last. But basically, you said in top of doing the checkpointing at the end, I was also doing a checkpoint every 10 seconds. So now if my job is killed because of memory, I can restart also from that one. So with this mode, basically having both, you basically have security to have regular checkpointing. In that case, you want typically to do not very often because that's not the most useful one. And you have on top of that, when at the end of the program is finishing, you have a checkpointing and automatic resubmissions in that case. Okay? That we have already said. So just a summary, basically, when you have a text editor, you never click on discard, and basically you should do the same for your jobs, right? All your jobs, I would say, should have checkpointing, because that's the way you are going to save a lot of time at the end of the day. Okay. In this case, I've only made a demo. All the files are available here, also in the Indico. If you have any issue to implement that in your own package, then come to me and then I can help obviously. I mean, it's nice to do, I mean, that you all work, but at the end of the time, it's a bit of a waste of time. I think like this, you have all the information. If you have any issue, don't hesitate to come back to us. Okay. Thank you. Yes, questions? Yes.
Does it take the same four conditions, which means the same time and same memory? Or
Yes.
it means it will start again with a new memory.
Yeah. But basically, the memory. I mean, if you are cancelled due to memory, it's likely that you are going to restart the job with the DMTCP. You are going to hit the memory limit very quickly as well, right? So your job is going to be cancelled again, much likely. If you have the time, I mean, Damien at some point show you with S-control, if I'm correct, how to change the property of some run via the command line interface. Then at that point, you can say, oh, my job is currently pending. So I don't think I did the cleaning. So you see, for the moment, my job is pending. I'm waiting to be allowed to be run in 5 minutes, right? So now if I can go there, and I mean, if Damien can tell me the commands, I can. Okay, it's S-control update, right?
Yes, and then job ID equals.
Job ID equal this. So 729.47142. And now that's the tricky part, is the name for the variables for the memory. So let's just memory equal, and then you can put the new number. I mean, that's not the correct syntax, but you can run this. That will update these jobs. It's too late now, it's running.
Yeah.
But
it's min memory CPU.
Everything uppercase?
Or lowercase.
Min memory
CPU.
memory CPU equal, and then you put the new value, something like that. Okay. And if you do that when it's pending, then your next job will be allowed more memory. Obviously now it's too, now it's running again, so it's too late. But for the next one, I could do that. But we need to change the job ID, obviously. Because job ID is updated, right?
When you requeue,
yes,
the job ID is kept.
It's kept, okay. So, but it's easy then. Yes, you see, it's indeed the same job ID. Now I can run this. You accept it. And now this one will have more memory. Okay. Any other questions? Okay. So that's it for today.